Namaste, my friend, and welcome back to NEET Physics with Typical Monk. This is class 3, and today, motion finally leaves the straight line. Think of a ball thrown across a field, a stone flung sideways, a satellite curving around the Earth. None of these travels in a single direction. To describe them, we need a new tool, the vector, a quantity that carries both a size and a direction at once. When Ria first met vectors, she tried to treat them like ordinary numbers and got lost. The day she learned to split every vector into its horizontal and vertical parts, projectiles and circles stopped frightening her. Today, one idea at a time, we learn to add vectors, to resolve them, and then to send bodies flying through the plane. Take a slow breath. Let us begin. So what will you carry home from today's class? First, vectors, how to add them by the triangle and parallelogram laws, and how to resolve one into two perpendicular components. Second, the two ways to multiply vectors, the dot product, which gives a scalar, and the cross product, which gives a new vector. Third, projectile motion, its range, its maximum height, and its time of flight, all flowing from a single launch velocity. Fourth, uniform circular motion with its centripetal acceleration and relative velocity when the motion lies in a plane. And fifth, the NEET drills, assertion and reason, mash the column and a full work numerical, so everything you learn today you can also score with. Ready? One idea at a time. Let us begin with the difference that starts everything. A vector is a quantity that carries both a magnitude and the direction. Velocity is a vector, force is a vector, displacement is a vector. Each one needs an arrow, not just a number. A scalar carries only a magnitude, a plain number with no direction. Mass, time, temperature, and speed are all scalars. Notice that speed is a scalar, while velocity is a vector. That single difference trips many students. To add two vectors, you place them head to tail. The tail of the second sits at the head of the first, and the arrow drawn from the very start to the very end is their sum. And the deepest trick of all, any vector can be split into two perpendicular components, one along the horizontal and one along the vertical. Argon only truly understood the plane the day he began resolving every vector this way. Now look at this diagram carefully, because it holds the whole grammar of vectors. The triangle law, place the tail of one vector at the head of the other, and the single side that closes the triangle is the resultant. The parallelogram law says the same thing another way. Draw both vectors from a common point, complete the parallelogram, and the diagonal from that point is the resultant R of A and B. The size of that resultant comes from the cosine of the angle between them. It is the square root of a squared plus b squared plus 2ab cosine theta. When the two point the same way, the resultant is largest. When opposite, it is smallest. And resolution is the reverse move. A single vector r at an angle theta splits into r cosine theta along the horizontal and r sine theta along the vertical. Prior learned to solve almost every plane problem just by resolving first and thinking later. Now, there are two very different ways to multiply two vectors, and NEET tests both. The dot product is a times b times the cosine of the angle between them, and the answer is a pure number, a scalar. It measures how much one vector lies along the other. The cross product is a times b times the sine of the angle, and this time, the answer is itself a new vector, pointing perpendicular to both. Two useful checks. Parallel vectors have a cross product of 0, because the sine of 0 is 0, and perpendicular vectors have a dot product of 0, because the cosine of 90 degrees is 0. And where do they appear? Work done is a dot product of force and displacement, while torque and angular momentum are cross products. Rohan remembered it simply: dot for a number, cross for a new direction. Time to solve a full NEET numerical together, slowly, the monk's way. A ball is thrown with a speed of 20 meters per second at an angle of 30 degrees above the ground, and we take g as 10 meters per second squared. We want its time of flight, its range, and its maximum height. Step 1. Write down what is given. The launch speed u is 20 meters per second. The angle is 30 degrees, and g is 10 meters per second squared. Never skip writing the given data. Step 2. Resolve the velocity. The horizontal part is u times cosine 30, about 17.3 meters per second. The vertical part is u times sine 30, which is 10 meters per second. Step 3. The time of flight. It is 2u sine theta divided by g, which is 2 times 10 over 10, giving 2 seconds in the air. Step 4. The range. Range is u squared sine of twice the angle over g, that is 400 times sine 60 over 10, giving about 34.6 meters. Another step 5. The maximum height. Height is u squared sine squared theta over 2g, that is 400 times 0.25 over 20, giving 5 meters. Resolve, then time, range, height. The same path solves every projectile NEET can set. Let us make the projectile picture permanent, because NEET returns to it every single year. The secret is to split the launch velocity into a steady, horizontal part, which never changes, and a vertical part, which gravity slows, stops, and reverses. Handle the two directions completely separately. The time of flight is 2u sine theta over g. It is set purely by the vertical motion, the time to rise and fall back down. The maximum height is u squared sine squared theta over 2g, reached at the very top of the arc, where the vertical velocity is momentarily 0. And the horizontal range is u squared sine of twice the angle over g. Now sit up straight. These 5 lines are what NEET actually asks year after year. Now one memorize the 3 projectile results goal: the range, the maximum height, and the time of flight, each written in terms of u, theta, and g. 2. The range is maximum at 45 degrees, and it is exactly equal for 2 complementary angles, like 30 and 60. 3. In uniform circular motion, the centripetal acceleration is v squared over r, and it always points toward the center, never along the motion. 4. Always resolve. Treat the horizontal and the vertical motions as 2 separate one-dimensional problems that share only the time. 5. Relative velocity in a plane is a vector subtraction. The velocity of one body minus the velocity of the other, and its direction matters as much as its size. Let us drill the NEET way. Remember the 4 options. Option A, both statements true and the reason explains the assertion. Option B, both true, but the reason does not explain the assertion. Option C, assertion true, reason false. Option D, assertion false, reason true. First one, assertion, the horizontal velocity of a projectile stays constant. Reason, gravity acts only in the vertical direction. Think, like, Ria. Check each statement alone, then check the link. Is the assertion true? Yes. Is the reason true? Yes. And does the reason explain the assertion? Perfectly. With no horizontal force, there is nothing to change the horizontal velocity. Both true. Reason explains. Option A. Second one, assertion. The range is the same for launch angles of 30 and 60 degrees. Reason. The range depends on the sine of twice the angle, and those 2 angles are complementary. Both are true, and the reason is exactly the cause. Sine of 60 and sine of 120 are equal. Both true. Reason explains. Option A. Third one, assertion. In uniform circular motion, the speed changes continuously. Reason. The centripetal acceleration points toward the center. Check the reason first. True, it does point inward. But the assertion is false. In uniform circular motion, the speed is constant. Only the direction of the velocity changes. The assertion is false. The reason is true. Option D. A quick match now. Say each answer aloud before I reveal it. Time of flight, 2u sin theta over g, said by the vertical motion alone. The maximum height, u squared sine squared theta over 2g, reached at the top of the path. Horizontal range, u squared sine of twice the angle over g, greatest at 45 degrees. And centripetal acceleration, b squared over r, always pointing toward the center of the circle. If all 4 came to you before the reveal, the projectile map is becoming yours. Here's a favorite new NEET format. I will read some statements. You silently count how many are correct. Statement 1. The horizontal velocity of a projectile never changes. Hold your verdict. Statement 2. In uniform circular motion, the velocity vector is constant. Think carefully before you answer. Statement 3. The range is maximum when the launch angle is 45 degrees. So, how many are correct? Two statements. The first and the third. The horizontal velocity truly stays constant because no horizontal force acts, and the range truly peaks at 45 degrees. But the second one falls. In circular motion, the speed is constant, yet the velocity vector keeps turning, so it is never constant. That single swap of speed for velocity is the trap NEET sets, and now you will not fall into it. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. In uniform circular motion, since the speed is fixed, there is no acceleration at all. It feels so natural, constant speed, so nothing is changing, no? Arjun believed this for months. But here is the truth. The direction of the velocity keeps turning, and a changing direction is a changing velocity. So there is always a centripetal acceleration pointing toward the center. Myth 2. The horizontal motion of a projectile slows down as it flies through the air. Surely the ball loses speed sideways too, no? The truth? With no horizontal force acting, the horizontal velocity stays exactly constant from launch to landing. Only the vertical part changes, pulled by gravity. Keep the two directions apart and you will never mix them up. Time to test yourself. Rapid fire. Here is the rule. I ask. You answer in your head before the reveal. No pen, no paper, just the projectile map you built today. Question 1. At what angle is the horizontal range maximum? 45 degrees. Question 2. If u sine theta is 10 meters per second and g is 10, what is the time of flight? 2u sine theta over g, which is 2 seconds. Question 3. For a speed of 10 meters per second on a circle of radius 5 meters, what is the centripetal acceleration? V squared over r, which is 100 over 5, 20 meters per second squared. Question 4. What is the dot product of two perpendicular vectors? 0, because the cosine of 90 degrees is 0. And question 5. For the same u sine theta of 10 and g of 10, what is the maximum height? U squared sine squared theta over 2g, which is 5 meters. If those came quickly, you have truly understood today's class. Let us gather the whole class in one slow breath. A vector carries both a magnitude and a direction. Add them head to tail, or by the parallelogram law. Any vector resolves into r cosine theta along the horizontal and r sine theta along the vertical. Always treat the two directions separately. For projectile, the range, the maximum height, and the time of flight all follow from the components of the launch velocity. The range is maximum at 45 degrees, and it is equal for any two complementary angles. Uniform circular motion always needs a centripetal acceleration, v squared over r, pointing toward the center. Our next class, the highest yield chapter of them all. Laws of motion, force, friction, and the free body diagram. Do not miss it. And so, my friend, motion has left the straight line, and you followed it into the plane. It may have looked like just arrows and a few projectile formulas, but understand this, the habit you built today, splitting every vector into its parts and following each direction on its own, is the habit that solves mechanics, circuits, and fields alike. Ria, Arjun, Priya, and Rohan all struggled with their first vector, exactly as you may have. And then it clicked, and never let them down again. Be patient with yourself. Tonight, draw one projectile and label its range, its height, and its time of flight slowly, once. One idea at a time. You will crack NEET. Of this, I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you in the next class.